Section 10.1 is graphing square root functions. For your learning target, you will be able to graph square root functions. And a square root function is a function that contains a square root with the independent variable in the radicand. So remember, your independent variable is your x. The parent function is f of x equals the square root of x. And your domain is going to be x is greater than or equal to 0, and your range for the parent function is y is greater than or equal to 0. So you can see that you have kind of like this starting point right here. So square root functions don't have a vertex. They have kind of like this starting point. And then your graph kind of looks like half a sideways parabola. Example 1 is describing the domain of a square root function. So when we're going to find the domain of a square root function, we're going to take what's inside the radicand and make it greater than or equal to 0. Because when we're taking the square root of anything, we need 0 or a positive number in here. So then we're going to go ahead and solve for x. And we get x is greater than or equal to -3. So this is the domain of our square root function. And if you check it by plugging in -3, we would get 0 in here, which is the smallest number we can get. We can't have a negative in here, but we can have any other positive number. Example 2 is graphing a square root function. And so we're graphing f of x equals the square root of x plus 4, and we're describing the range of the function. So we're going to start this problem the same way we started example 1. We're going to take what's inside the radical and make it greater than or equal to 0. Here, there's nothing for us to solve for x. So when we make our xy table, we're going to follow that inequality for our x values. So that means I'm going to start at 0. And I can do 1, 2, 3, and 4, let's say. So when I plug in 0, I get the square root of 0 plus 4. The square root is what you're going to calculate first. If you're following PEMDAS, your square root you can write as an exponent of 1/2. So it's kind of like doing your exponent first. So we're going to calculate the square root of 0 first, which is 0, and then 0 plus 4 is 4. Plugging in 1, the square root of 1 is 1. 1 plus 4 is 5. So now 2 and 3 are not perfect squares. If you have a calculator to use, we can plug those in to calculate their values. Otherwise, it might be easier to just plug in 4 because 4 is a perfect square. So when I plug in 4, the square root of 4 is 2, and 2 plus 4 is 6. So then if you were thinking if you wanted another point and you wanted to plug in a perfect square, that number would be 9. So you can go ahead and start graphing this. So we have 0, 4, 1, 5, and then I'm going to jump over to 4, 6, and then draw in my graph. So see how it's just like half of that sideways parabola. So then the last part is to describe our range. And your range still deals with the y value of that starting point, kind of like how in the quadratics we dealt with the y value of our vertex. So our range here is that y is greater than or equal to 4. So this page has just some more notes, and it basically goes over all of these transformations that we've been looking at since chapter 3. So they've shown up a couple of times in our different types of functions, and all those transformations apply again in our square root functions. So this is something that you've already learned about a few times. Now we're just going to be applying them to our square root functions. So for example 3, you're comparing square root functions. And so for this one, we're actually going to be comparing it to the parent function. So I've already graphed this. This was from example 2 as well. But now we want to write what the comparison is or the transformation of this one. So since we have this plus 4 on the outside, this is going to be a translation up 4. So example 4 is looking at our multiple transformations. So it says describe the transformations from the parent function, and then we're going to graph this. So first we're looking at this 3 in front, and this is going to give us a vertical stretch by a factor of 3. Then we're looking at this +1 on the inside. That is going to be a translation left 1. And then finally, we're looking at this -3 out here. So that's also going to be a translation down 3. So these are all of your transformations for this one. So now we want to go ahead and start our graph. So again, you're still going to take what's inside and make it greater than or equal to 0 and solve for x. So I end up getting x is greater than or equal to -1. So when I start my table, I want to start it with -1 and then use numbers that are greater than that. So we're going to go ahead and plug in -1. -1 plus 1 is 0. The square root of 0 is 0. 0 times 3 is 0. And 0 minus 3 is -3. So what hopefully you noticed is that this also gives you your starting point, kind of like how you're given your vertex when it's in graphing form of a quadratic. Same thing here. You do the opposite of what's in this, and then you keep this second value. So we have -1, 3. So when we plug in 0, 0 plus 1 is 1. The square root of 1 is 1. 1 times 3 is 3, and 3 minus 3 is 0. When we plug in 1 and 2, we're not going to get perfect squares because 1 plus 1 is 2, 2 plus 1 is 3. So if you have a calculator, you can calculate those decimal values as well. Otherwise, we can plug in 3 because 3 plus 1 is 4, and that's a perfect square. So 3 plus 1 is 4. The square root of 4 is 2. 2 times 3 is 6. 6 minus 3 is 3. So we can go ahead and plot these points. So we have -1, -3, 0, 0, and then 3, 3. And here's our function for this one.